data, both for measuring central tendency or dispersion. We usually build a frequency distribution table to analyze a data set. How to build a frequency distribution table? Uh, First, we need to group the data in our data set in different kinds of category. Uh, it is also referred as class interval. For our convenience and by convention, we build our class interval like this. The first one, 64 to 69. Why 64? Because 64 is the lowest score here. Second one, 70 to 74, and so on until this one. So for this interval, the range is 5, or the bin is 5. 0 plus 4, the bin is not 5, 4. 0 plus 4 equals 4, 5 plus 4, 9. So the range is 4, 4. And the first one and the last one, a little bit special, because we need a bigger interval for the first one and the last one, just for our convenience. That means mostly the intervals are equal, but the first one and the last one, it is not necessary to be equal. So class in frequency for the first one, how many data points fall in this interval? Look at this data. We have only one, 64. 64. Oh, what? 70 to 74. How many data points fall in there? 70 to 74. Check the data set. No, 0. 75 to 79. We have 1, 75 and 78. Okay, we have 2. 80 to 84. 80 to 84. I want to point out that the class interval include the boundary point. For example, this category include 18 and 84. So we have 81. We have 80 this one, and then 83. So we have 2 here. And 85 to 89. 85 to 89. We have 85, 1, 88, and another 88. So we have 3. 90 to 94. We have 91, so we only have 1 here. Okay. 95 to 99, we have a 96, so we only have one. We add up all the number here. 1 plus 2 plus 2, 5, 8, 9, 10. Totally is 10. So we are right here. If you add up all the frequency, you got 11. That means you made a mistake. Class frequency, now you know what it means. It just means the data point in this category. Relative frequency for this interval, relative frequency is 1 over 10 equals 10%. For this category, relative frequency is 0 over 10 equals 10%. For this category, class frequency or relative frequency is the class frequency 2 over 10, 20%. Because we usually express relative frequency as percent, so I convert fraction to percentage. Relative frequency, just the class frequency divided by the number of the data point or the size of the data set. So for this class, we have again 2 over 10, 20%. For 85 to 89, we have 3 over 10, 30%. 90 to 94, we have 1 over 10, 10%. The last one, 1 over 10, 10%. If we add R, all the relative frequency from all the category, we shall got 100. Let's do the calculation. 10%, 30%, 50%, 80%, 90%, 100%. Cumulative frequency. What is cumulative frequency? Cumulative frequency, the first category, 1 The second category is 1 plus 0 equals 3. For this category, cumulative frequencies, we already have, oh my goodness, how could I make this big mistake? I made a very stupid mistake here. 1 plus 0 equals 1. For this category, cumulative frequency is 1 plus 2 1 plus 2 equals 3. For this category, cumulative frequency is 3 plus 2 equals 5. Now you know the pattern. Cumulative frequency just these categories frequency plus the previous order class frequency. It is accumulate. Actually, just accumulate all the frequency together. So for these categories, cumulative frequency is 5 plus 3. 5 plus 3. A. The next one is equals to the previous one plus the next one's frequency. A plus 1 equals 9. The last one, 9 plus 1 equals 10. The last cumulative frequency must equals to the size of the data set. Let's go to the cumulative relative frequency. Oh, more and more complicated. Cumulative relative frequency based on to calculate it, we need to use this column based on this column, and then do the relative calculation. Relative, when you see the word relative, just remember divide by the size of data set. So for the first category 1, divided by the size of data set 10 is 10%. The second category, this one, 1, again, 1 over 10, 10%. So cumulative relative frequency just correspondingly the cumulative frequency divides by the size of the data. For this one,